All right, this PowerPoint goes around with lesson 6. All right, so we have SOLIDWORKS Teacher Guide lesson 6, and what we're going to be discussing in lesson 6 is drawings, engineering drawings. Drawings communicate 3 things about the objects they represent. The shape, views communicate the shape of an object, so the views communicate the shape of an object. The size, dimensions communicate the size of an object. And other information, notes communicate non-graphic information about manufacturing processes such as drill, ream, bore, paint, plate, grind, heat, treat, remove burrs, and so forth. Samples of engineering drawings. So here is a little thingamabob, and here's a section view. We know how to do that. We've created section views before. And then we have side views with descriptors and measurements. We have isometric views, and then we put our name over here and the part name. The general characteristics of an object will determine what views are required to describe its shape. Most objects can be described using 3 properly selected views. Sometimes you can use fewer. However, sometimes more are needed. Why do we need 3 views? The front and top views of both parts are identical. The right side view is necessary to show the characteristic shape. When 3 is not enough. 3 standard views do not fully describe the shape of a cutout in an angled face. All right, so we have a shape here. We have a top view, a right view, and another top view. All right, so we have added a view over here to the side. The right side view is unnecessary. All right, so we have top, front, isometric. And then this is the right side. Dimensions. There are 2 kinds of dimensions. Size dimensions, how big is the feature? All right, so here are size dimensions added to it. And location dimensions, where is the feature? So these tell the measurements on the sides. This is the diameter of the circle, and this tells how far the circle is from the bottom and how far the circle is from the side, so it tells you the location. For flat pieces, given the thickness dimensions in the edge view and all other dimensions in the outline view. All right, so we have all these dimensions added so that you can see the dimensions in various ways. Dimension features in the view where they can be seen true size and shape. All right, so once again we see all of these, whether it's a curvature, radius of curvature, or whether it's the length, or whether it's the distance, or location, or diameter. Use diameter dimensions for circles. Use radial dimensions for arcs. Right? So here's our radial dimensions, and here's our diameter dimensions. Omit unnecessary dimensions. All right. Just give some specifics. Don't use all the dimensions, because then it just becomes confusing for someone to read, unless you need to use the specifics. So have all the specifics that you need to convey, but don't have unnecessary specifics. Place dimensions away from the profile lines. Allow space between individual dimensions. A gap must exist between the profile lines and the extension lines. The size and style of leader line, text, and arrows should be consistent throughout the drawing. Display only the number of decimal places required for manufacturing precision. Neatness counts. All right, so we have a bunch of dimensions in here. These are all different sizes, the text, different fonts, different boldness, arrows going all over the place. This is not good. Much better. All right, same measurements only everything is in the same font size, and it's nice and neat. It looks consistent. Notice we have an isometric view, a top view, a front view, and a right view. A drawing template is the foundation for drawing information. A drawing template specifies the sheet or paper size, orientation, landscape, or portrait in the sheet format, borders, title block, data forms, and tables such as bill of materials or revision history. Standard SOLIDWORKS drawing template, tutorial drawing template, custom template, no template. All right, click on the new standard bar and then click on draw. And we already use the same standard template for all our drawings that we've been using in this class. So we'll continue to use that same template. There's a variety of templates, but we always use the same one. So we'll continue for these practical purposes. You can also obviously open the part that you wanted and then use the make drawing in the toolbar to do that, or you can go straight to draw to get the template. Click on the tutorial tab. You won't need to do that. You can skip that part. And then double click on the drawing icon. All right, so we opened the same thing. We won't need to use this tutorial, but we can open parts, assemblies, or drawings, or go straight to drawings if we want to, and we'll see the preview just the same. All right, this is the sample of the drawing template we've been using all year. There are two modes in the drawing. Edit sheet. This is the mode you use to make detailed drawings. Use 99+% of the time. Add or modify views. Add or modify dimensions. Add or modify text notes. Edit sheet format. Change the title, block size, text headings. Change the border, incorporate a company logo, add standard text that appears on every drawing. The title block contains vital part and or assembly information. Each company can have a unique version of the title block. Typical title block information: company name, part number, revision sheet number, tolerance, drawing scale, sheet, revision, drawn by, check by. Edit the title block. All right, right-click in the graphics area, that's this middle, and select Edit Sheet Format from the shortcut menu. So you can go ahead and try that. Zoom in and out on the title block. Zoom in with your little rolly scrolly. Double-click the note that says Company Name. The Property Manager and the pop-up formatting toolbar appear. So you see all this stuff? Isn't that nice? You got your fonts, angles, arrows. Enter your school name in the text insertion box. So SOLIDWORKS Corporation, you'll add Aquinas Institute. Set the letter justification to align left and change the size and style of the text font. So you got formatting right here, all this stuff. Colors, bold, index, underline, type of font, number, size, spacing, centered. Click OK and apply the changes to close the Property Manager. Position the note so it is centered in the space. Centered, see? Advanced topic. The name of the part or assembly shown on the drawing changes with every new drawing. It is not very efficient to have to edit the sheet format and the title block each time you make a new drawing. It would be nice if the title block would automatically be filled in with the name of the part or assembly that is shown on the drawing. This can be done. Advanced topic. Click InOut on the annotation toolbar or click Insert Annotations Note. The Property Manager appears. Ooh, look at that. Click the Link to Property button. Click Model and View, specified in Sheet Properties, and choose SW File Name from the list of properties. So there you go, SW file name. Click OK to add the property. Advanced topic. In the property manager, set any other text properties such as justification or font. Advanced topic. Click OK to apply the changes and close the property manager. Results. Currently, the title block shows the text of the property. However, when the first view is added to the drawing, the text will change to become the file name of the reference part or assembly. Right-click in the graphics area and select Edit Sheet from the shortcut menu. All right, right-click in the graphics area, right-click, and then you can do Edit Sheet. This is the mode you must be in when you make drawings. Dimension standards. Dimensioning standards determine things such as arrowhead size, style, and dimension text positions. There's an arrowhead right there. The tutorial drawing template uses the ISO standard. ISO standard stands for International Organization of Standardization. ISO is widely used in European countries. Ooh, isn't that fancy? Dimensioning standards. ANSI is widely used in the United States. ANSI stands for American National Standards Institute. Other standards include BSI, British Standards Institute, and DIN, Deutsche Industries Normen. Customize the drawing template to use the ANSI standard. Setting the dimension standards. Click Tools Options. All right, there you go, ANSI. Click the Document tab up here. Click Detailing right there. Select ANSI from the Dimension Standards list. Dimension Standards list, ANSI. Then click OK. Setting text format fonts. Click Tools Options. Click the Document Properties tab. Click Annotations font. Select the annotation type from the list. Setting text fonts continued. The Choose Font dialog appears. You look at all these fonts. There's a sample of what it looks like when you pick it. Then you can get bold or italic, or even bold italic if you feel like getting crazy. You can have the point size. You can have underline or strikeout effect. Make the desired changes and click OK. Click File, Save As. From the Save As Type list, click Drawing Templates. The system automatically jumps to the directory where the templates were installed. Click Blank to create a new folder. Name the new folder Custom. Browse to the custom folder. Enter ANSI size A for the file name, just like it does there. Click Save. Drawing template have the suffix .drwdot. Open the part or assembly you wish to detail. Open a new drawing of the desired size. Add views, usually 3 standard views plus any specialized views such as detail, auxiliary, or section views. Insert the dimensions and arrange the dimensions on the drawing. Add additional sheets, views, and or notes if required. Click Standard 3 View. Select Tutor 1 from the Windows menu. All right, so Tutor 1 is your drawing. So you're going to have to create this in Lesson 6, and you have the 3 standard views. Then click OK. The drawing window appears. Make sure you put your name on it, and then you're going to upload it to OneNote to submit. To select the view, click on the view boundary. The view boundary is displayed in green. Drawing views 2 and 3 are aligned with view 1. Drag drawing view 1 front, drawing view 2 top, and drawing view 3 right. Stay aligned in a drawing view. Drawing view 3 can only be dragged left or right. Drawing view 2 can only be dragged up or down. Hidden line representations. There they are, hidden lines. Hidden lines visible is usually used in orthographic views. Hidden lines removed is usually used in isometric views. Tangent edges displayed. Right-click inside the view border, select tangent edges removed from the shortcut menu. You right-click in the display. The dimensions used to create the part can be imported into the drawing. Dimensions can be added manually using the dimension tool. Looks like this. Associativity. Changing the values of imported dimensions will change the part. You cannot change the values of manually inserted dimensions. Click Model Item and then the Dimensions button on the Annotation toolbar, or click Insert Model Items. So we see that right there. Click the Import Item into All Views checkbox. Import items. Click on the option marked for drawing. Right there. Eliminate duplicates. Click OK. Check mark. Moving dimensions. Click the dimension text. Drag the dimension to the desired location. To move a dimension into a different view, press and hold the Shift key while you drag it. Deleting dimensions. Click the dimension text and then press the Delete key. Flipping the arrows. Click the dimension text. A green dot appears on the dimension arrows. Click on the dot to flip the arrows in and out. Flippity flap, flippity flap. Position the views. All right, look at this. We got all these nice views in here. Arrange the dimensions by dragging them. Set hidden line removal and tangent edge display. Changing dimension on the drawing changes the model. Double-click the dimension text. Enter a new value. Rebuild. Bleep, blap. Open the part. The part reflects the new value. What? That's cray-cray. Open the assembly. The assembly also reflects the new value. Drawings can contain more than one sheet. The first drawing sheet contains tutor 1. The second drawing sheet contains the tutor assembly. Use the B-size landscape 11 by 17 drawing sheet format. Add 3 standard views. Add an isometric view of the assembly. The isometric view is the model view. All right, so here we have the 3 views of the assembly. A model view shows the part or assembly in a specific orientation. Examples of model views are standard views such as front, top, or isometric, user-defined views, orientations that were created in the part or assembly, the current view in the part or assembly. Click Model View or click Insert Drawing View Model. Click inside the border of an existing view. Do not click directly on one of the parts in the assembly. Doing so will create a named view of that specific part. So see, it click over to the side because it's all in the box. But if I clicked on this, it would just be the front. If I clicked on that, it would just be the back. You want everything. A selection of the model view icon appears in the property manager. Here we go. Here's all types of things. Current model, trimetric, dimetric, isometric, all standard ones, front, back, sideways. Select the desired view, in this case isometric, this guy right here, from the selection. Place the view in the desired location on the drawing. There it is. We put it right there. So we had our standard 3 views, and we have our isometric view. Put our name on it. Submit it through Microsoft OneNote to the teacher, Mr. Noon. Detail view. Used to show a large view of something. Click this A with a circle on it. Insert drawing view detail. Sketch a circle in the source view. Position the view on the drawing. Edit the label. Change the scale. Import dimensions or drag them into view. So here you click on this tool and then you draw that circle that comes with it into here, and then all of a sudden it pops up. This is the detailed view of what's in this circle area. So it's like a zoom in, and then you make sure you have all these dimensions added to it. Section view, used to show internal aspects or object. Click this cross section or drawing view section. Sketch line in the source view. Position the view on the drawing. Section view is automatically crosshatched. Okay, so I pick this on the bar and I pull this across like I draw a line, drag it over here, and then all of a sudden pops up the cross section down here. Double click the section line to reverse arrows. And that's the end of our slideshow. Here, let's do this. All right, so now you can start lesson 6. All right, so you can follow these directions, create tutor 1. So we already had tutor 1 and tutor 2. So here's tutor 1, and then you're going to create 6 drawings. So 1, 2, 3, 4, 5 drawings are shown on the front page. This drawing we created in our PowerPoint, and then this drawing we created in a PowerPoint. So that's 2 drawings that you'll need to submit with all the specifications. So we're going to use the SolidWorks drawing tutorials to create these. So let me open this real quick. SolidWorks. And then we have under help, tutorials, and we have here getting started. Here's our drawings. So we follow these instructions on how to create these drawings, how to add dimensions, modifying dimensions, all of this, inserting another view, creating an isometric view. And then we have those 2 drawings, just like we had in our PowerPoint presentation. All right, so you have to create these 2 drawings and submit them to answer these questions in OneNote. And then this is the 3rd drawing. This is the back, tutor 2, with all of these. I'll follow all the directions to create it like that. 1, 2, 3, 4. So this is the 4th one. This is our CD box. This is the 5th one. This is our CD box with the CDs. And then this is our 6th and final drawing that we have to submit. This is the switch plate with our import view, our detailed view, and all the dimensions put in here for the switch plate. All right, so go ahead and do all that, and then make sure you also answer the questions so you can watch the next video on how to do these things and follow the directions to do that. So go ahead, get started, and then complete your work. Thank you. Have a great day.